This is part 8 of the recording of the Module 5 lecture. And here we'll continue showing some examples of the use of the Poisson probability distribution. Now, in this example, and I doubted whether or not to include this example, but I wanted to show you the limitations that we encounter using tables to find probabilities, or even to do calculations using the binomial probability formula. But let's look at this example. So the occurrence of potholes on a highway after a torrential rain follow a Poisson probability distribution with a mean of 5 potholes per mile. They're asking us to find the probability that there are exactly 30 potholes in a 5-mile section of the highway. Also asking us what is the probability that there are more than 30 potholes in a 5-mile stretch of a highway. All right, let's look at this example. So they tell us that this is a Poisson probability, the holes form following a Poisson probability distribution. So in here, the random variable counts the number of potholes in 1-mile section. And when you see the values of the random variable could be 0 to infinity. Okay, the potholes occur randomly in 1-mile section of highway, and it can be assumed that the potholes occur independently in any 1-mile section of highway. Now, they are giving us the average of potholes that occur in 1-mile section, yet the question is asking us about the potholes in a 5-mile stretch. So lambda is given for the number of the average potholes, which is 5 per mile. But in the question, they are asking us what is the number of potholes in a 5-mile section of the highway. So here it is expected to find the same number of potholes per each mile. So in this case, we can just multiply the parameter by 5 because lambda is for 1 mile, but we're looking for a stretch of 5 miles. So we multiply lambda by 5. So the average occurrence is that 25 potholes in a 5-mile stretch of highway. All right, with this, then we can find the probability of finding exactly 30 potholes in a 5-mile stretch. So using the Poisson formula to calculate probabilities, so in here the random variable is 30, then is e to the minus 5 times lambda, then is 5 times lambda to the 30th power, and divide by the 30 factorial. All right, so in this type of calculation, you really need to use your calculator. So you need to know how to calculate the exponential value to the minus 25. And also you need to calculate 30 factorial because this is a very large number. And also this is 25 to the 30th power, another large number. So your calculator should be able to handle these calculations, if it is a scientific calculator, that is. All right, if you carry out this calculation, you find the probability is 0.0454. Therefore, we say the probability of finding exactly 30 potholes in any 5 miles section of a highway is 0.0454 or 4.54%. All right, so this is the first part of the problem. In part B, they're asking us to find the probability that there are more than 30 potholes in a 5-mile stretch of highway. So this is what they're asking is to calculate the probability that a random variable takes on values larger than 30. That will be x is equal to 31, x equal to 32, and so on until infinity. Or we can use the complement of this event. And the complement of the event that the random variable is more than 30 is that the random variable is less than or equal than 30. So we use that complement and to find this probability. So we do 1 minus the probability of x less than or equal to 30, which is 1 minus the probability of the random variable being equal to 0, being equal to 1, all the way to being equal to 30. Either way, you see a lot of calculations. And if you rely on the tables that the book provides in the Appendix B, Well, we cannot solve this problem with those tables because they have tables up to a lambda value of 20. So in this case, we have to rely on some software package. So in here, we'll use Excel to calculate this probability. And so the reason I included this problem is to show you the limitations that we run into when we rely on tables or probabilities. So here, the software is the best choice to calculate probabilities. All right, so in Excel, we're going to use the formula 1 equals 1 minus Poisson.dist, 30, 25, and true. 30 is the number of the value of the random variable that we're interested in finding out. 25 is the value of lambda. In this case, it's 5 times lambda, which is 25. And true, this instruction is telling Excel to calculate the cumulative probability from 0 to 30. That's what this will do. So this true ensures that this part is calculated. And so, of course, we're doing 1 minus that. That will give us the probability that we want. So if you enter that formula in Excel, you will get a result of 0.13669. By the way, if you look at the recording of calculated Poisson probabilities with Excel, I have a little section where I show how to do this, enter this formula and obtain this value. All right, with this value obtained using Excel, then we can say that the probability of finding more than 30 potholes in any 1 5-mile interval is 0.1367 or 13.67%. All right, so this is this example. The next example I wanted to talk to you is about one where we're going to use Excel to construct a Poisson probability distribution. In this example, the U.S. Department of Transportation maintains statistics of mishandled bags per 1,000 airline passengers. So in 2013, this department released this information where it says that Delta mishandled 2.91 bags per 1,000 averages, implying that this is the average of bags mishandled by Delta per 1,000 passengers. So now they're asking us, what is the probability that in the next 1,000 passengers, Delta will have no mishandled bags, at least 1 mishandled bag, and at least 2 mishandled bags. So in this case, what we're going to do is we're going to use Excel to construct the Poisson probability distribution. And we're going to use this formula. So equal Poisson.dist, parentheses, X being the number of occurrences that we're interested in finding, lambda, the average value of mishandled bags, and false because we want to find exact probabilities. So in this case, I enter 0 through 12. And remember, this could go to infinity. But you can see that by the time we reach 11, the probability is almost 0. And by 12 is almost 0. So this is the Poisson probability distribution for a lambda value of 2.19, which is what we have right here. All right. And so please look at this video and you see how this is calculated. And also using Excel, I produce a graph of this probability distribution. Again, in an exam, if necessary, I will give you this table. So all you need to know, use the probabilities in this table to answer the questions in the problem. Right? And I'm doing this because it's difficult to provide during the exam the tables in the back of the book. So rather than doing that, I'm going to show you the probability distribution, and then you can use it to answer the questions in the problem, like in this example. For example, the first question here says that what is the probability of no mishandled bags? In other words, what is the probability that the random variable is equal to 0? Well, that one is right here. So X is 0, and this is the probability that the random variable is equal to 0. So the answer is the probability that Delta will not mishandle any bags for the next 1,000 passengers will be 0.1119 or 11.19%. In the next question, it says the probability, what is the probability of at least 1 mishandled bag? that means the probability x is larger than or equal than 1. Again, because this table goes on forever, the best thing to do is use the complement. So the complement of x being larger or equal than 1 is the probability that x is equal to 0. That is the complement of this event. So in here we do 1 minus the probability of x equals to 0, which is given right here on the table. So you subtract that from 1 and you find 0.8881. So the probability that delta will mishandle at least one bag for the next 1,000 passengers that travel with delta will be 0.8881 or 88.8%. Now the third question, and we'll use this table again for this purpose, it says what is the probability of at least 2 mishandled bags? So the probability that the random variable is 2 or larger. Again, we use the complement of this event to calculate the probability. And the probability that x is larger or equal than 2 is the probability that x is less than or equal to 1. And I have the wrong probability statement here. I will correct the slides and repost them with the correct statement here. But you can see that the probability there are 2 or more bags mishandled is 1 minus the probability that there are 0 bags mishandled or 1 bag mishandled. So these two probabilities come from the table right here. So we do 1 minus the addition of these two and we get 0.643. So the probability the delta will mishandle at least 2 bags of the next 1,000 bags is 0.643 or 64.3%. All right, so this is an example of how you can solve these problems when you are provided with the probability distribution. All right, as we mentioned before, a random variable always has its own mean and its own standard deviation and its own variance. We saw what that is for the binomial and for the hypergeometric. Well, for the Poisson random variable, that's not an exception. So the mean of the Poisson random variable is not surprised, is the value of lambda. What is surprising is that the variance of the Poisson distribution is lambda, and the standard deviation is the square root of lambda. So 2 things to note here. One, the possible values of the Poisson random variable go from 0 to infinity. So that's one thing to remember, which is different from the binomial and the hypergeometric distributions. And the Poisson probability distribution is defined by a single parameter, lambda. All right, with this, we're done discussing all the discrete probability distributions. So we're finished with Module 5. And so if you look at the schedule of the course, the Module 5 assignment is divided into 2 parts. The first part is due this week and the next part next week. Again, please see the calendar on Wiley Plus to see what is due this week, which is these are the recordings that were posted earlier. And then these latter recordings correspond to the assignment that will be due next weekend. All right. And finally, what I like to do is review what we should have learned in this module. So you should be able to explain what a random variable is, distinguish between a discrete and a continuous random variable, explain what a probability distribution and what conditions it must satisfy, calculate the mean and the variance of a random variable, list the characteristics of a binomial experiment, calculate probabilities for a binomial random variable, its mean and standard deviation, list the characteristics of a hypergeometric experiment and calculate probabilities, list the conditions to calculate the probabilities for a Poisson random variable and its mean and its standard deviation. So we're finished with Module 5.